Okay.
Okay.
All
So
right.
there
Okay.
we
I'm
go.
sorry. I didn't think about
All right.
that.
So we missed a lot, but then the next presentation will be fully recorded. So, and I actually can go back. I can really go back and record the other part if it's helpful. I don't mind doing that. So just, talking through. Susan, think about that. If you want me to go back a little bit later and record the first half, I don't mind doing that.
I would really love it if you would.
Oh, my pleasure. Yeah, I'll just do it as soon as we end here.
Okay.
Okay, so back to, here we go. Okay, so the laser show like so. We're going to get into some E&M stuff. Whiteboard electronic whiteboard circuits. Very simple. You take bulbs, a little bit of magnetic tape on the back of them, works great. The night you can set something up on the board and have kids build it at their desk. Nothing
cool.
to it. Magnetic tape, having a roll or two of that stuff around is wonderful. This is, I don't know why this gets me so excited, but it's so simple. So that's a meter stick on just like a convex surface. And all that is basically a thin plastic rod. It's cut from a golf tube, like the insert of a golf bag. And all I did was rub it with fur. And
wow.
And it polarizes the stick and it attracts it beautifully. And you can do both sides of it. I don't show, this is just a GIF where I showed part of it. But the next thing, this is maybe even more. Oh, by the way, I've done this with a 2x4, like a 8-foot long 2x4, and it works just as well. And it's way more impressive than the meter stick or a 2-meter stick or whatever. Yeah, it will rotate. It's stunning to kids to see that a little bit of electrostatic charge will do that.
You said that was a golf tube?
That's all this is. It's a thin wall. It's thin wall PVC.
Okay.
So if you could probably just get PVC at a hardware store, one long piece of PVC, thin stuff, the thinnest you can find, and just cut it into, like, I don't know, cut it into, geez, it was 50, half a meter long pieces, something like that. That and a piece of fur. I have this thing. I don't know how long I've had it, but it seems to be magic. It's just so simple. I've just had it forever. Here's a variation on that works beautifully. I did this yesterday just because I normally wait and do my electrostatic stuff right around the winter. And I was afraid that it wouldn't do anything, but no, this is yesterday. Soda can, same plastic rod.
Yay.
It's as simple as it gets.
Oh, they'd have so much fun with that.
It's really simple. And I've actually I will even have students just do that as part of a lab. Electrostatics labs I've always found to be very tedious, and they're trying to repeat things. So I just try and make it the most obvious things that are always going to work. That one's always going to work. DIY resistor boards, usually once, I don't know, I think I've only had to do it once. I just bought, I think on eBay, maybe eBay or Amazon, I just bought like a dozen 10 ohm resistors, a dozen 15 ohm resistors. I think they were all $1 or $2 each, and just spent an evening in front of the TV once, just made little DIY resistor cards. It was either that or buy decade boxes, and decade boxes tend to be about $100 each. So
yeah.
These are very simple, and that's the front of them. I did a couple of needle holes there. That's the back of them, and they're also marked here so students can basically connect. And when you do an intro to Ohm's law lab, they can just go down through all these, and you generate a beautiful curve, obviously. Homopolar motors, very simple. They're just fun to chat about what's really going on. I stole those images because I didn't happen to have one laying around, but all it is basically just one wire bent and with a neodymium magnet that you can kind of barely see there. Maybe no, actually it's on the bottom, but the thing will spin very nicely. This is for the truly ambitious. But you can make a cheap, large Tesla coil. I've been dragging this thing around most of my life, it seems. This is copper tubing that's held in place with some, this took some work and time, I will confess that. But I'm glad that I still have it and it still works fine. So that's copper tubing. That's one way to make a primary coil out of copper tubing. I use it to support my meter sticks now. And then over here, this is a construction tube, a sono tube. That's looks like it's about 10 inches in diameter. And that's just like 18 gauge wire that's wrapped around it. If you don't want to do it, you'll find a student who will. And basically that's the secondary coil, and that's a Tesla coil. That's all there is to it, really. You need a big transformer, like a neon sign transformer works. You can find those all the time. You know, people have broken neon signs, and it's always the glass that breaks, never the transformer. So I have a half a dozen of them laying around that people have just brought in and given me. So I use a 15,000 volt transformer for it. Works well. You can use you can actually find for about $5. You can find a really big high voltage capacitor that works. It's not even that. It's like, I don't have it handy, but it sits in the palm of your hand. It's high voltage. It works fine. You can also make a capacitor with bottles. This is way more dramatic, and it sounds and looks dangerous, but it's not. So these are all bottles, and they're filled with salt water. And then in this is basically a Tupperware, a Rubbermaid container, also filled with salt water. And then these are connected in parallel. There's a wire, you can't see it, here's a wire on one end that goes in. And this is basically just a big capacitor, very high voltage capacitor. And the nice thing is once you get it working, you get sparks all through here as well. It's very dramatic. This is the kind of thing that I recommend if you have the time, or if you have a student who's really interested and you can supervise them. They really can't hurt themselves, but on the other hand, I'm not going to, I'm going to watch them, you know, but it's one of those things that if you invest the time in it, you'll be happy you did, but it takes a few hours to put together. It's the most labor intensive thing by far that I'll be talking about. But if I didn't like it so much, I wouldn't have even mentioned it. All right, a handful of miscellaneous things. There's a few demonstration I actually forgot to list here, like little dynamics carts and dolls on them for demonstrating the effectiveness of seat belts. 3D printed meter stick connectors. It's kind of useful if you have access to a 3D printer to just make little things that will connect them together. Works really well. You can get some aluminum thresholds at a Home Depot that work like dynamics tracks, and they're a lot cheaper. And I think each one costs about $20 or so. And the wheels usually fit in the grooves pretty well. They have different grooves on them. So you have to go take a dynamics cart with you, but they work pretty well. I now have the you know, the good joy. It's been a while since I've had my own classroom, but now it's nice to have a room where you can really let it reflect your you know, basically let it be a good advertising for physics is what I try and do. So my room definitely does that. There's an applause sign there. Usually when I have my students, it was really simple and very cheap, and it's connected to a simple push button on off switch. So if I want to, you know, if a student will do something, hey, round of applause for my assistant, you know, it's one more thing to kind of get them engaged and excited. And that's the name of the game at my school. 2-meter sticks are hard to find, but they're really useful. Oddly enough, you can find 3 and 4 and 5-meter sticks pretty easily. They're surveyor's tools, and they tend to cost around $30 each. I never knew how badly I needed them until I got them. So it's nice to be able to use them to quickly measure the height of your ceiling. You can also do things like attach a string over it, and you can do, it's easier to do falling object experiments sometimes. So anyway, 3 and 4 and 5 meters. I think I've gotten mine off of eBay, but they're all about $30 each. They are surveyor's tools, but they are calibrated in centimeters.
Awesome.
I have a constant reminder of 1 meter in my room up on top of my whiteboard. There's just like a couple of 1 meter long tapes that are marked just so students are like, hey, what's a meter? I don't remember what a meter is. Like, it's right there. And likewise over here by my closet, this is about a 4 meter, it's about a 3 meter tape. And the students can just quickly go and measure their own height if they're interested, and everything is in centimeters. So it gets them thinking in SI all the time. Well, right. That's the dream anyway.
Exactly.
Yeah. Using the ceiling again, having screw eyes, washers, nuts, that creates a nice strong place to hang things, whether it's bowling ball or you know, the bosun's chair or the block and tackle. This photo from a few years ago, the OSIRIS-REx spacecraft, is one that my students are always usually surprised by because they always think that the moon is really close. And so usually at some point when I talk about size and structure, especially if I'm teaching astronomy, I will say how, I'll hold like a baseball and a globe. It's about the right size difference. Say, okay, tell me where I should stop where you think the moon is. And, I'll get barely far away from it to think, oh, stop. It's like, nope, not only that, but here's an actual photo, which is probably not even as far apart as they really are. But there's an actual photo that you can see the size and scale difference. So as a constant reminder of this, I have in my room a globe hanging on one corner of the room, and then the opposite corner of the room, the right scale distance away, is a softball that's actually painted to look like the moon. You can get a 3D printed moon also. And the distance, I measured it, it's pretty close. I would have had to have a slightly bigger room for it to be correct, but it's like within 85% of the actual scale difference. They should be separated by about 110 moons. So it's usually very, very surprising to students to see that. It's good to have a north, south, east, west designation on your floor or even up against your wall. I had a sticker there that I put, but I think my maintenance folks thought it was graffiti. So I haven't marked it permanently, but I will. I just did that the other day just so I can remember, which way is actually north. When it comes up, if we talk about vectors, it's nice to know. Using the outside, I've got a shed outside. It's actually a container, but any small shed is worth having if you have gasoline engines or things like that. We had an observatory that was actually donated. Both of these were donated, so they were. It's very convenient and nice to have around. Obviously, having an astronomy as part of my background, I love having an observatory handy. Teaching units is usually kind of boring. I used to think that, but now I found it to be way more interesting because they talk about the history of units, what a meter actually is, where it comes from, what a liter is, and how a kilogram is related to that. So if you happen to have, you can find these sometimes. I don't even know where I found mine, but it's basically, this is just a liter box. It's 10 centimeters by 10 centimeters by 10 centimeters. Fill it with water, and it's a kilogram. And that was the original definition. You can make one of these yourself. It's a light nanosecond bar. It's just a tiny bit shy of 1 foot. And it'll show students how far light will travel in a billionth of a second. When we talk about the meaning of the second, have set up a 1 meter long pendulum and measure the period. It's 2 seconds, and then talk about where the original second came from. And then when we get into the period of a pendulum, they always, well, at least I used to be surprised, like, why does it work out so perfectly that a 1 meter long pendulum has a 2 second period? Magnetic tape I mentioned earlier, worthwhile to have. It's nice, especially if you teach AP physics and you get into, if you're teaching APC and you get into unit vectors, I like having a 3-dimensional coordinate system handy. It's good for IJ and K components. Sometimes I'll put a little flag on them for IJ and K. This is one of those things that I've always wanted to learn how to do some animation. And sometimes if I need quick animation, I'll do it via Google Slides. You literally can create a bunch of animation and then either play the animation, or I actually did a screencast of it. So when I was talking about special relativity and length contraction, when I do the derivation of the rotating clock, it's really nice to kind of show how the light pulse moves back and forth and why it's a shorter distance right to left than left to right. So it's very simple. It's clunky, but if you need to quickly do animation, that's one way to do it. Or you can, there's apps and you can teach yourself. I just haven't gotten around to that yet.
Now, I'm sorry, was that a Screencast-O-Matic? Is that a?
Oh yeah, I have that listed here as well. Screencast-O-Matic is free. It's really useful to create lessons that teach themselves. I'll get to that in just a moment. These are some worthwhile purchases that I thought, yeah, they were a little expensive, but I found that I used them way more often than, graphical analysis and video analysis and larger, they're not that expensive. They're, but you already have a substitute. You have Pivot Interactive. That's
well, we also have Vernier.
That's what these are. These are Vernier. So I think those are really, really worth the investment. I found that I like having a high capacity digital scale that for hanging stuff. And this one goes up to, I think, 200 kilograms. So it's awesome. I like having an inside outside satellite clock and thermometer. It's, you know, and you can have it set on Celsius.
Mhm.
I keep time zone clocks, and then I also have, I forgot to take a picture of, but I have the latitude and longitude of my classroom listed as like on the door, as a, this is where you are. It's plus or minus 50 meters, I think. So it might be plus or minus 10 meters. I can't remember. If you're worried about how noisy your students are, have a decibel meter on the wall. They make cheap digital ones now. And then, so here's some of the photos. There's the decibel meter right there. That's USB powered. There's a satellite clock. And I like, again, having the 3 clocks with different time zones handy, because often we'll talk about time. There's the high capacity digital scale. Now, these, I won't go into all these. These are tons of resources that I seem to use a lot. Screencast-O-Matic is great. It is the one that it's self-teaching, and literally if I have to create a little, okay, so for example, I was teaching students how to use the lens formula. 1 over f equals 1 over I plus 1 over O, or di plus 1 over do, whatever. And I find that some students have a really hard time doing that. So what I'll do is I'll create a 3-minute video with that, talking them through it. And you can use, if you have a touch screen, you can use Jamboard with Google Slides, or if you're using Zoom, you can do that. You can use the whiteboard function. Anything that has a whiteboard function, you can record it, and then it's really simple. You don't have to have your face on it, or you can. So entirely up to you.
Is it free? Is that one free?
Oh, it's all free. It's all web-based too.
Ooh.
So, well, I take that back. When you save the video, you save it on your computer.
Right.
So Sky Maps, if you teach astronomy, free star maps. Easy GIF is great. I like to create GIFs, so I'll shoot maybe a video and just, you know, it takes me, as long as it takes me to film it, it's probably about that length to make a GIF out of it. You can do it on your phone too. I find it easier to use Easy GIF. Animated Engines is one of the greatest sites online. And if you ever talk about thermodynamics, it's just so wonderful to show students basically how different cycles work. And it's really simple. And it shows everything. If you teach chemistry, you can talk about the nature of the explosion, the expansion, and the contraction when the exhaust gases are expelled. It's wonderful. And there's a dozen different engines on it. I'm sure you know about PhET. That's great physics classroom, same thing. I don't know if you know about Falstad. He's a guy who does some of the greatest online. They're a little out of date, some of them, but his Ripple tank is wonderful.
Oh, wow.
Yeah. And the other thing, and there's like, I don't know, several different things. It's better than any actual Ripple tank. And of course, you can change the speed. You can change the resolution. You can add damping. You can change the frequency. You can change the brightness, and then you can go to multiple sources if you want, so students can start to see interference. There are Doppler effect simulations. There's just so many different things. It's so simple and beautiful. Oh, the best thing, 3D.
Wow.
Yeah.
I'm sorry, I'm easily impressed.
Oh, my students will stare at this. They'll be, oh my God, it's so beautiful. Yeah. And oh gosh, you know what? He has so many other ones that are really good. His things for electric fields are stunning. Where are they? He has an electric field app that's really great. Oh, here it is. I think this is it. So yeah, so he'll show you. You can reverse it and change. So now, yeah. And then if you want, you can display particles, or you can display field vectors. It's also in 3D.
Ooh.
You can display potentials, and you can display the forces. So it's fantastic. And again, 3D nature is, of course, this is showing a slice rather. You can show it in no slicing. So it's beautiful. This guy is a great programmer. Let's see what else. If you have students do your students use Google Slides? Are you a Google school? This is actually a really good, there's a link to a really good organizer here. There's so many organizers. I think this one's really good if you have students who need some organization help. There's a bunch of other things here that are great. Academo is wonderful for, this is cool. It's a virtual oscilloscope. I don't know if you've ever seen this before, but it's everybody's got an oscilloscope now for sound. So yeah.
That's amazing. And that was very cheap.
Free, right?
Yes.
When we talk about the issue of going through the earth, students will say, what'll happen if I drill through the earth? Well, you can just take them to something like Antipodes map and they'll get the exact location on the opposite side of the earth.
Oh, that's cool.
Yeah, and there's a few of those on here. There's some
click on the Google Sheet student organizer for me.
Oh, of course, yes.
Got me intrigued.
Oh yeah, definitely. All you do is you click on this and you'll make a copy of it. And yeah, click on that and you'll pull up a copy. You want to make a copy? Sure, it'll save it into your Google Drive and open it up for you. And so basically what you have here is a color coded thing, and you can change the dates every year. So
that's awesome.
That's for August, and then you can click down there for September. Yeah, this is
nice.
Out of date, but you get the, it was literally this school year. So yeah,
that's awesome.
Yeah, it goes all the way up to it goes all the way up to now. I mean, I've had my own kids do it, and my one child likes it, the other one wants nothing to do with it. So I like it. Omni Calculator is one of the good calculators online that has a whole lot of stuff that people have written good things for. Let's see if, you know what, I just put the general link here, but it has many different tools for physics. There's 400 different calculators.
For the upper school campus. Any 11th graders who have not turned in their Chromebook, please do so now at the IT office. Again, this upper school page is for 11th graders to turn in their Chromebook. Thank you.
Okay, so there's many different calculators here that are, do some things online, especially if it's a more complicated thing. Omni Calculator is great. There are so many of these Desmos, obviously. GeoGebra is a really classic one. Actually, I'm sorry, this is PhET, but I like this because this shows you how sine and cosine works. Let's see, GeoGebra has some wonderful stuff. And like, for example, you can see, if you ever teach calculus, you can see how the slope changes, how there's the function, the instantaneous rate of change will give you a different function. So, and so many other things. There's a great online tone generator. And you can show octaves immediately, or, you can change the frequency by decimals. There's a handful of other things here. This one is a really good relativity calculator that will allow you to get better results than you can get from a regular calculator. So if they want to see what's the effect of traveling basically at the speed of sound relativistically, that should allow you to calculate it. You normally can't get that effect from a regular calculator.
Right.
Let's see that. Let's see what else I have here. Oh, the online keyboard. Also, when talking about music, it gets into some of the gory details, and you can actually show how chords and scales are constructed. If you have students who are really interested in that, I actually do a sound lab where they learn a little bit about that. I'm sure I'm skipping some things. Oh, let's see. O Physics is also really good. It uses GeoGebra, I think, and it will show, wave superposition. It's got many different things. Just go up here to, there's dozens of things here with their physics simulations. That's it. There you go. That was well over an hour. So let's take maybe a short break, and then I'll talk about some building stuff.
All right. I will.
Any other questions or anything? So
no, it's amazing.
Thank you. I want also thanks to Susan too for inviting me. So. And if you ever need to get in touch with me, you'll have my email address, but so feel free to reach out anytime.
All right.
Okay, so maybe like a sorry?
I was just gonna say how long a break?
Like a 5-minute break or so. Okay, thank you. Hello. Hey. Hold on one second. I'm actually. Hello.
I'm trying. There we go.
Hey. Are ready to go again?
Yes.
Okay. I hope we're still, yeah, we're still recording. Okay, so I realized boy, oh boy, that was really long. And so I hope this one won't be as long. Okay, I hope I don't hold you back.
I am learning so much.
Oh, I'm so glad. Well, I'm going to when I'm done, I'm going to make a recording of the first half as well. And that way, in case you want to see it again, or Susan wants to, there'll be a copy of it available.
Susan wants it.
Oh, definitely. Actually, I can either send the video file or I can load it onto YouTube. Either way, Susan, let me know what's more convenient for you.
I think probably put it on the YouTube.
I will gladly do that.
John, I don't know how you feel about this, but I wouldn't mind if you just put it out and let it be there.
Okay. Not at
I mean,
all.
How do you feel about that?
Oh, I don't mind. I don't mind. I'm not doing anything
Okay.
that's like, I don't mind whatsoever. So,
Thank you.
yes, my pleasure. My pleasure. And Susan, I shared the slides with you as well. And yeah. All righty. Well, let's start part 2.
Can I ask a question?
Oh, yeah.
Okay, I see. Oh, never mind. I got both of them. They're both PDFs. What we just did, the PowerPoint you just did was a PDF.
No, so I sent the PDFs, but I also
Okay.
shared. If you look, it should say something is shared with you. If you go into you'd have to go into your email, and it should say something has been shared with you.
Google Slides. Yes.
And those are the actual slides that have all of the GIFs and live video and things.
I got it. Okay. Thank you. I was just looking forward to make sure I had it because it was a wealth of stuff I have wanted in my life.
All right. Wow. I never hear that. So, okay. So let's talk about some building ideas. And like I said, I think because it's just you, I'm going to trust that you can build things on your own time. And when you, because I've already talked for an hour and a half, and this might just keep you here too long. So let's get started. Are you seeing my slides?
Yes, sir.
Awesome. Okay, so I did call this building things in physics classes. And the reason is, of course, I have found out the older I've gotten, the less my students have worked with their hands. And, well, you know, I mean, in physics, we've got, I think, a pretty good opportunity to fix that. So I'm going to, excuse me.
This time, Krajik Gammon, please come to the office. Krajik
I
Gammon.
forget you guys are still in school.
I know we are until, yeah, we've got literally 3 more days or so. And we have field exams, which means that our final exams this year are going to be sort of on, we're taking kids to DC one day to have some, I wrote some physics challenges for them there, determine how tall the Washington Monument is, determine how long it would take a ball to fall from the top of the Washington Monument, you know, predict. Determine the volume of the reflecting pool by the Lincoln Memorial, determine how tall things are, determine how tall the Martin Luther King Monument is, things like that. How to find the circumference of the Hirshhorn Gallery, which is a round building. And there's a lot of things that made it, you know, we went down a couple of months ago to write some challenges. And DC is just, you know, 45 minutes, an hour from here. So. Okay, so some ideas for building things. Let me just give you a bunch of ideas. And there's also more here than you probably will ever have time to do. But, you know, these are great for advanced classes. They're great for intro classes. And most of these things you can do at any level you want. So once again, we'll start off with mechanics. Hot Wheels track. So if you have a 3D printer handy, this is the greatest thing available. It's a little download file where you can print out whiteboard clips, and you can just stick your Hot Wheels track right on the wall, glue a magnet to them with super glue or epoxy. I think I use Gorilla Glue, and this fits right in Hot Wheels track. And it's awesome because it allows you to have some really ornate loops and things on the walls if you want. It's virtually free. If you see here, there's actually a PhotoGate timer taped to there. And then, you know, you can get more ornate if you want. You can usually buy rolls of Hot Wheel track, 50 to 100 feet of it. I found that's a little bit expensive and sometimes hard to find, but it's kind of worth it, especially if you only have to buy 1 or 2. So it ends up being about $40, I think, for a roll of 50 or 100 feet. I can't remember the last time I bought it. But if you go to a dollar store, you can also find individual 2-feet tracks for $1 each. So. And with those tracks, I usually set up, just take a little piece of 1x2 board. Oh, by the way, let me say, some of these are things, most of these are things that students can build, but some of these are things that I've built. So that's why, you know, it can be either one. This is Hot Wheels, obviously. That's a little dedicated photo gate that has 2 LEDs in it, and it gives the speed of the car directly at the bottom. You can find cheap lab jacks on eBay or Amazon, but 2x4 chunks work really well for quick lab jacks, and they don't cost anything. Find your shop teacher and have them cut you about 20 different chunks. During COVID, we gave take-home physics kits, and sometimes if we're gonna have a student who's gonna be out for a while, there's some great, put it in a Ziploc bag, give some string. Fishing weights, you can usually buy a bag of fishing weights on Amazon, give them 2 or 3 or more, a ruler, measuring tapes. Usually I get measuring tapes and I put an X on the side that says inches, just to remind them to always use metric. Protractor, a binder clip is good if they have to attach something to a door frame. A spare pencil. If you are doing circuit stuff, these are things that are really useful and cheap. Bulbs, wires, sockets. You can find multimeters now that are under $10. Batteries, enameled wire, magnets, and then maybe hot marbles, maybe a Hot Wheels car, maybe super balls or something like that. So again, take-home physics kit, probably about a $15 investment. If you do electricity, it's probably about a $5 investment if you don't do electricity. I mean, if you don't want them to do electricity stuff at home. You think you said you saw this one earlier? Yeah, there's nothing to that. That's a coat hanger and a couple of tennis balls. But it's a really nice center of mass thing. Also, if the student turns around, they'll notice that the balls will stay put, which is also a nice inertia demo. Clay works well too. I don't know if you've ever had students build bridges before, but so many different ways to do it. I'm a fan of using basswood. It seems to work well, and it's pretty strong without being impossible to break, unless you're my student Catherine, and I couldn't break hers no matter what. Hers was amazing. So I usually require a 30-centimeter separation. There is a maximum weight of the actual bridge requirement, or I give them a penalty. I attach a small block of wood in here, and there's an eye bolt and a chain that goes through and supports kilogram masses. I have them design it first. And this is my favorite online truss simulator. This one, you literally just click and drag, and then you click over to members, and you can add members really easily. And then once you get it set up, you can have it do the calculation for it, and it'll give you all the tensile or compressive forces. You add weights to it. It's pretty intuitive to use. Literally play around with it and you figure out how it works. It's pretty simple. It also tells you if the bridge is unsolvable. So if they have too many members and not enough data points, then it'll say it's we can't solve it. Let's see, hold on, building things, there we are. So you can I've had students use gusset plates before, but I don't do it anymore because it makes it too ugly and it's not necessary. But if you want them to, if they're having a hard time, I've had students use like little pieces of manila folder cut out to act as a gusset plate over the joints, but they don't need it. And just white glue. Everybody uses the same material. Mobiles, that's a great project and it's really simple. Has to be balanced. They should give you the moment or torque calculations. I usually say it should say something about them, and I usually provide dowel rods and string. So it's a nice, simple torque project. The car project was one of the things I would have you build today. Have you ever had students build these before?
Yes.
Really simple. It works so well, but the thing I like about it is I do it pretty early in the semester. And at least with my regular class. With my conceptual class, I actually have them do it later in the year because we start with waves and then eventually get into the more mathy stuff like mechanics by the last third of the year. And we start with waves and then electricity. I'm sorry, waves, then optics, then electricity, and then mechanics. And it actually works pretty well, oddly enough, just because the math builds. My regular academic classes, we start off with, with mechanics. But I like it because especially if they've never built anything before, it just kind of forces them to get their hands dirty right away within the first couple of weeks. It's a bunch of different kinds. I like using propellers too. So propellers are kind of fun. And so you can use balloons, you can use propellers, you can use mouse traps. It's way more challenging. There's different ways. Rubber bands. They shoot a phone video. And then we do the video analysis. We'll get with video analysis, you click on the axes and that'll change whether it's your X position, your Y position, X velocity or Y velocity. There's the velocity of that particular thing. And that one was kind of erratic. I can't remember which one was this absolutely stunningly smooth. So, remember where that one came from. If you do model rockets, you can pay for them and you can buy all kind of Estes parts. You can also have students do a little bit of design, make their own 3D printed rocket parts, whether it's a nose cone or fin units. And pretty easy to do that if you have students who are 3D printing savvy. So, thank you very much. You're welcome. So nice. Thank you. So, that's kind of useful too. And again, you can purchase parts in bulk, and that's fine too. For my advanced class, I like to have them design their own. I just give them parts and say, just design it. I have a small wind tunnel, we can test it. And even if you don't have a wind tunnel, you can do balance tests by swinging it around in a circle on a string. If you really want to get good data, you can get a little altimeter. And these are awesome. They are about $75, and you want to put it in a rocket you know will not get lost. So I haven't had to lose one yet, but because I only have one right now. But these things are amazing because they're USB charged. They have pressure sensors in them, so they know to start taking data when it takes off. It'll give you the acceleration. It'll give you the full thrust time. It'll give you the peak altitude. It'll even give you the burnout velocity.
I'll call it for the upper school at this time. Could all faculty please report to the cafeteria for the faculty meeting at this time? Could all faculty report to the cafeteria for the faculty meeting?
It'll give you all the data you need, basically. It's great. It gives you a lot. And they have a newer version, the Altimeter 3, which I think actually will interface and give you the full set of graphable data if you want that. I haven't bought one of those, but that's pretty awesome too. If you want to have students build launch pads, it's pretty simple. These are, I mean, you can buy launch pads or you can build them for just a couple of bucks. That's a chunk of 4x4. I stole this idea. These are shelf brackets that you'd have laying around. A little piece of steel here for a blast deflector. It doesn't have to be that. You can literally just have anything. It can be a coffee can lid on top, but that might be sharp. So there's a link to this if you want. And you drill a hole for the rod. If you're feeling ambitious, you can build a multi launcher. I built one of these that wasn't this pretty, but so I stole this image from Rocketry Works, but they sell this for like $250, which is insane because it's PVC. So that's about like $20 for the PVC right here and a couple of adapters. I've done a projectile launcher project before where students have to build something that gives repeatable results. It can be a catapult, it can be a ballista, it can be rubber band powered, it can be spring powered, it can be a trebuchet. It's just got to give you some repeatable results, and they have to determine the initial velocity. And then usually I would say, okay, on the day of the testing, so I want you to hit a target located here. Or you can just say, you know, it has to actually, you can tell them what the range has to be in the first place. You can say it's got to be, hit something that's 5 meters away or whatever. Some fluids and pressure building ideas. Kites are a great project that are really simple. I actually put in some of my notes here. I didn't derive any of the equations, but I tell you the important things that are worth calculating if you want them to calculate stuff. So the actual lift equation, which is about the same as it is for a glider, is this. They can measure a lot of these things from a photograph of their kite flying. They can get the angle of attack. It should be in radians. They can get the span, the greatest distance across. They can get something called the aspect ratio, which is kind of like it is on a screen. It's just the span squared divided by the surface area. There's some other things that can be calculated that are related to the drag and the shape effects. I won't get into all those details. You can look all this. There's a really good NASA page on kites. And then they can, then usually what I have them do is I have them calculate all these things. Wait, where is it? It's here somewhere. There it is. All these things they calculate as part of their project. They have to weigh it as well.
I'm sorry, what was the C? I don't know what C
A
is.
C is the lift coefficient.
Oh, okay, okay.
And yeah, that's it's called the corrected lift coefficient. And it takes into consideration these things called the inclination effect, which is basically the fact that it's at an angle, and the thing called a downwash difference, which has to do with the different pressure on the top and the bottom. I can't remember exactly how it's defined, but it's some other. It gives
Oh, there it is.
Yeah, it gives an adjusted lift coefficient that gets it to be a more realistic portrayal of the kite. So the actual lift coefficient is this, and it's given by this expression, which comes from this expression originally. So yeah, that's how you can calculate the lift if you know the aspect ratio and if you know these two different lift coefficient effects. And the cool thing is that, you know, it's fun to build the kite, but then they can also see there's a lot of physics that goes into something as simple as a kite. Here's some good links for kites. I generally recommend building Delta kites first. Box kites are cool, but they are harder to do well, I think.
Don't fly during a thunderstorm. I'm sorry, that was funny.
Yeah, I did that accidentally once. I was at a beach. There is a story. I was at a beach. I noticed my hand started to tingle, and I'm looking around. At some point, it dawned on me to look around, and there was nobody else there at the beach. And I noticed these clouds everywhere, and I was like, "This is about the stupidest thing I've ever done in my life." And so the smart person would have dropped the kite and ran away, but I really, really liked that kite, so I spooled it in as quickly as I could and ran away with my kite. But yeah, don't fly during a thunderstorm. That could have been a really dumb way for a physicist to die. Dowel rods are great. They're pretty cheap for 1/8 inch or so. You can get fiberglass rods, but they're more expensive. Ripstop nylon is really good stuff. You can also use garbage bag plastic. It's not as pretty, but it works well. Plastic sheeting. You can take Tyvek. You can use cut up IKEA bags. You know, any kind of big plastic bags work well. Newspaper, if you want to be super cheap. Hot air balloons. I've taught courses in flight before, and hot air balloons are a lot of fun to build. I have a really bad drawing of how they work here. It's usually 3 or 4 sides, or many sides in this case. They just have to determine the volume of it. And you can use, I forgot to put the calculations in here, but you basically use, I think, Charles' law or Gay-Lussac's law, and you can determine, is it Charles' law? I think it's Charles' law. Is that volume and temperature? Yeah, it's one of the gas laws. So and you can use a hairdryer, or a heat gun tends to work better. So, and that'll get it to rise. And, you know, it's mostly for fun, but you can also predict the temperature necessary to make it lift. You can, even if you're feeling a little bit crazier, and I used to do this with my first ones, have a small opening here with a frame on the bottom. And the frame would have a couple of thin wires, and you could put a cotton ball that has some rubbing alcohol on it, and you can light that and allow the flame of that to allow it works really well. But if there's wind, it will catch it on fire. So
Oh, man.
yeah, watch that. And there's all kind of different templates for the gores for the sides of them, and you can find dozens of those available online. I usually have students just whatever they build, they just have to determine the volume of it. So if it's going to be ellipsoidal, they have to find the volume of an ellipsoid equation and all that stuff. The calculations, I'll fix this a little bit later. This should actually be earlier in the slide set. Okay, some E&M builds. Simple electroscopes, one that you probably built before. You can do this with Erlenmeyer flasks and a rubber stopper, and you know, anything that'll go through the top. It just has to be conductive. You can also do this as a basic electroscope. Just a styrofoam cup, straw, string. That is just a little styrofoam ball that has, it's a pith ball, but I think it's basically a styrofoam ball that I painted with graphite. So works really well. A couple things I didn't have handy and didn't have time to build, but you can build an electrophorus very easily. That will allow you to do some electrostatics demonstrations. It's just a chunk of styrofoam, aluminum pie plate, styrofoam cup, and normally you just hit it a few times with fur, and you can talk about how charges move from one place to the other. I like this. I don't usually do them because I think they're a little bit complicated to understand. If you want to build capacitors that will actually shock students, not painfully, but they will shock, a plastic cup and 2 foil cupcake liners, one on the outside, one on the inside. And you can charge these up with a Van de Graaff generator, and they will surprisingly shock you. Not painful, but alarming. The world's simplest motor. I know you've probably done this before. This is there's definitely materials for the workshop available for you to take home for this. 10 to 20 turns of thin enameled wire, probably 22 or 24 gauge. You want to wrap it around the coil itself, sand off the ends. Some people say to sand off only half the end. Sand off the whole thing. It's too hard to do half an end, and it doesn't make a big difference. This is a coil. It doesn't actually have a split ring commutator like most motors do have. So you don't need it. It actually works well without it. Its own momentum will keep it going for a while. Here, I'm just kind of testing it out for symmetry. So that's the basic thing. You definitely want to have you have your magnet. It's very simple to build. Have you had students do these before?
Yes.
Yeah, very simple. Electromagnets are worthwhile to do, and especially using them to show how a telegraph works. Also very simple. Have students be careful because with something like this, it will get hot. Speakers. Speakers are easy and they're great. They a little cup, a neodymium magnet, and a coil of wire. I generally recommend you do about 50 turns of wire for this, and it should be symmetrical to the ring magnet itself. So you basically go around it. And oh yeah, I've got the description there. You can't see it super well in this picture, but it actually doesn't make a huge difference. But I find that it works a little bit better if you've got the like the bottom of your cup, you kind of have the magnet. Even if you want, you can put a magnet on the inside and the outside, and it'll stay there. But you can just glue it or tape the magnet in place, and then have your coil go around it. About 50 turns of wire is enough. And then sand the ends of the coil so you can attach it to wires that will go to an 1/8 inch jack. You can then take the 1/8 inch jack and plug it directly into the bottom of a phone. I'm just now realizing that this phone doesn't have an 1/8 inch jack on it. Oh, well. So, but, or an iPod or anything. It doesn't actually have to be, it can be any kind of stereo that has an output. If it's a little boom box or something, then you can just use a 1/4 inch jack if it needs it, whichever size you need. But if it's a phone, if students have older phones, they'll probably still have 1/8 inch jacks. Or if they have Droids phones, they'll probably still have 1/8 inch jacks. They're stereo, so this is only going to be mono, but it will give proof of concept. Same sort of thing right here. Does that make sense? Because I think I'm being pretty clunky about how to do that.
No, it makes sense.
Okay. The yeah, I like doing this one. It's really simple, and it actually works in reverse too. It works as a microphone. So literally, you can just talk into it and have it record things. You can put it as a microphone into a computer with an 1/8 inch jack into the microphone input, so it can record into an MP3 player. I have just been known to use an old cassette recorder and have it plug in. You can record your voice immediately with this. Old microphones weren't much different than this. It was a tin can and some coil and something to a magnet. That was it. Yep. Again, it does work as a speaker and as a microphone. That's not the only way to do. You can also do microphones or speakers with piezoelectric sensors. They work just as well. They sound a little bit different, but they work pretty well. They'll also work as guitar pickups too. So you just attach it directly to the guitar anywhere and it'll pick up the sound. It's got 2 leads coming out, and that can get attached to a 1/4 inch cable for a guitar to go into an amplifier, or an 1/8 inch cable to go into a into a computer. Again, being a musician, I like talking about, I talk about guitar pickups and how they work. They're actually pretty subtle, and guitar pickups have not been around as long as microphones have been. So the microphone has been around for well over 100 years, but a guitar pickup only goes back to, I think, the 20s or the 30s. And they're actually simple, but it's a bit weird how they work. So you take a bolt, and I usually use a bobbin. And you can see that's all basically wrapped up with hundreds of turns of copper wire, thin enameled wire. It doesn't even need that much, but it's louder the more turns you have. But literally, if you do just a few dozen turns, it's going to work no matter what. And you put a magnet on top, and that's it. And then you just have to have a metal string is important because the metal will vibrate. And as it vibrates, the magnet will induce a current in the metal string. The metal string will then get a magnetic field around it, which will induce a current in the bobbin. And it's a really strange, mutual sort of thing, but that's how any kind of pickup works. And well, I take that back. That's how most pickups work. There are microphonic pickups that are, like the other kind. And then if it's a 6-string guitar, you could have 6 of these in a row. There's all kind of ways, but I think for just proof of concept for a single string pickup, that's how they work. It's actually pretty simple. And the physics is it's amazingly complicated for such a simple device. But yeah, you get your thin enameled wire and some kind of metal guitar string. And it can literally be just you know, a wire that's just stretched between a couple of weights. Oh, and there's all sorts of links here for building more. If you get into some circuitry, this is my favorite circuit to have students build. It's complicated, it's a challenge, but it works really well. It's just a blinker, but if they change the capacitor value, you change the blink rate. Now, the reason why I do this is it is actually kind of hard to do. You normally start, anytime you're building something like this, I usually start from the inside out. Start with the chip, it's a 555 timer, and then build this on a breadboard, no soldering. 9-volt, got a couple of resistors here, a capacitor and an LED, and the thing just basically blinks. That's all there is to it. But the thing I like about this is if I'm doing a whole unit on electronics nowadays, I tend to get into, after this, I'll get into like Arduinos. And with an Arduino, you don't need any of this. You literally just can change the code and it changes the blink rate. So then if you really have time to do a whole couple of weeks on Arduinos, or better yet, Circuit Playground Express, which I think is easier. There's all kind of info here about Arduinos that uses this idea called physical computing. I'm not a programmer, but you don't really have to be to do some stuff with CPX. So CPX is cool because it basically uses this, and that's about the actual size of it. You can hold it in the palm of your hand. Have you ever seen these before? They're great. They're about $10 each. And all these little things you see here are sensors. These are all touch sensors. All these things you see here are LEDs. There's an accelerometer in it. There is there's memory chips to actually store the code. It's pretty useful. This is where you learn how to do it, and literally you can teach yourself in about 10 minutes because the code is all click and drag. Yeah. It is literally as simple as creating a loop by clicking on the loop, pulling it over. And then if you wanted to do something with the lights, you click on them. It's really simple. And by clicking, it automatically writes the code for you.
Well, that's nice.
It is great. It's really good. If you're trying to teach any basics of programming, you can choose the pause right here as part of the loop. This pauses for a second. And then I think when I was done with this one, it makes it do this. Yeah, all it did was it blinked back and forth. And then if you change the code up a little bit, you can make it basically do a countdown. So I've actually, yeah, students do as a project something that has to be, I don't know, it can be health oriented. It can wake them up. It can, because it can be, you can make it act as an alarm. It can be something. I had a student build one once where it would help them. It would give an alarm if they were to doze off. Like if they're driving, you wear it. If you doze off, it'll give you an alarm. So, and again, these are about $5 or $10 each. They're really cheap. For Arduino, they're also amazing. They're just, I think the CPX is easier because this still requires you to write code, whereas the CPX, it's an option. And that's also, they're also about palm sized. And there's some info on Arduinos there, including a full 80-page guide with a bunch of different sketches in it for programs. There's the software. There's a book that gives you a bunch of examples. This is usually how I have my students start, just following this. If you have time over the summer to play, have you done Arduinos before?
No.
Yeah, kind of useful. I've seen a lot of people in the maker movement doing really cool stuff with them. Like I've seen people do something like they were designing toys for autistic children that if somebody was upset, they squeeze this toy, and based on the little amount of programming, it would kind of vibrate more and more, or it would like do something. I can't remember exactly what it did, but it was specially designed for kids with sensory issues. A wired house project. Have you done this one? Yeah, this is great. My colleague just did this one last week. I really like this. I haven't done this one in a few years, but I was really impressed with her students. And so I think this is really cool. Give them, by the way, the cheapest option I found is to just go to a dollar store, get a few strands of holiday lights, Christmas lights, whatever, and just butcher them. They're usually somewhere between 3 and 6 volts per bulb. And that's enough. Give them a half a dozen bulbs without having to buy actual bulbs and sockets. Here's some cheapo series and parallel boards for you. This costs about, I don't know, $1. I think you can make a dozen of these without buying, crazy. These are just alligator clips that are screwed onto a board, and also give, oh my gosh, a couple of batteries. And yeah, I think these were using, they had like 1.5 volt bulbs or something like that, that just had little leads on them. I think I used the holiday lights for these too. Some waves, sound, and optic stuff. A good project here is wind chimes. Pretty simple project. You can use aluminum or steel or copper and a hacksaw. When I need to cut things in my room, I actually have a portable, I mentioned this later in the slides, a portable vise. And you can get these for like $20. So they literally just clamp onto a table with a clamp underneath. And yeah, it's really solid, and you can just remove it. If you don't have a place for a permanent vise, it's nice to have 1 or 2 temporary vices handy. So there's the formula for you. The length is equal to the speed of sound divided by 2 times whatever frequency you want. If you're not musical, you can just do like a C major scale, or there's one that I built actually years ago, and it's hanging on my porch right now. So, and there's just basically your basic notes right here. So if you did like a C, you could start anywhere here, and a C major scale just goes all the regular letters C, D, E, F, G, A, B, and back to C, which would be twice whatever that is. You can also do it with pipes of pan, like using straws, and it's the same idea and way easier for students to make. And literally, I've done this as a project, but sometimes it's better as an extra credit thing. If a student didn't do so well in the sound unit, say, here, try this on your own, and bring this in when it's done. It's because it can be extra work that you might not have the time to have them do in class. And especially if it's a kid who's really good with their hands, right?
Right.
Simple wave machine. I've seen people do really easy versions of this with just a strip of duct tape on both sides. They can be dowel rods, or they can just be barbecue skewers, which is way cheaper. And either put gumdrops or candies or balls of clay on each side. And that's it. The whole thing is super simple. It can be horizontal, can also be vertical. I don't use candy just because I want it to last a little longer,
Right.
But you can use candy, you can use gummy candy or whatever. Balls of clay work. Ideally, you just have it so that they're the same size. So if you want to make it more ambitious, you can have rubber tubing and dowel rods and wooden balls on each side. That'll cost a little bit more, but they're kind of pretty. I've done musical instruments as a project before, where students can make a tin whistle or a cigar box guitar, pipes of pan, tune glasses of water, anything that they just have to tune it. It has to be tuned to, like a regular major scale. And with that, I give them the frequencies, and I just ask them to play a basic song on it, like a Mary Had a Little Lamb or something like that. I don't do that every year. It really depends on how much my students get into the music unit. This kind of a simple Ray Optics light box. This is just a shoebox. Probably should have had this in the demo slide set. And that's just, I cut it with a knife. That's wax paper. So when you put a light bulb inside through the hole in the bottom, lights up, and you can really easily in a dark room see a nice inverted arrow. You can do it with candle flames too, but sometimes it's easier to see with the arrow. I did that. That was pretty clunky. I did that really quickly yesterday. So
It's pretty for really quick,
what's that?
but it's pretty for you doing it really quickly.
Yeah, it's just kind of a mess there, but that's the idea. Okay, some miscellaneous building stuff here. Oh, I got a ton of ideas that I didn't even get into. I like doing holograms. That's what I studied in graduate school first time. And you can do liddyhollow.com is a great place to go to check out their hologram sets. It's not hard to do. Low power lasers. You get started for under $100. Acoustic levitation. This is amazingly good for a project. If you have a student who really wants to try something different in engineering, literally you can levitate small things with sound by setting up multiple waves hitting and creating nodes. And you can actually suspend small pieces of styrofoam and stuff. It's I had a student do that as a long-term project once. That was really pretty cool. And I can't remember who makes this now, but if you Google acoustic levitation, you'll find a kit that you can buy. 3D photographs. I don't do that so much anymore, but you can simply by having two pictures taken approximately a little bit further than an eye length apart, and then using a 3D viewer, you can see in 3D. You can trick your brain into seeing in 3D. Radio telescope is repurposing an old satellite dish to be able to read the sun, or maybe even a couple of large radio emitters like Cassiopeia A. I haven't done that in a few years. I'm building one right now, but it's sort of kind of just in the beginning stages of it. Let's see. Sometimes a project I've had students do is a manila structure. How strong of something can they take by taking one manila file folder envelope and white glue? How strong of a structure can you make? Spaghetti bridge is a classic, spaghetti and epoxy, but it's messy. We do it at Hopkins in the summertime. It's messy. A Rube Goldberg device, you can decide whatever it has to do. It can light a candle, it can put out a candle. Those are my two favorites, but it can do anything. And with that, I usually just have them, they have to cite all of the different energy transformations. Crystal radio is completely a long dead interest, but it's still kind of neat to make radios out of simple devices. And I didn't put the specs in here for that, but literally you could take a paper towel roll, wrap wire around it, get a diode, do a little bit of sanding, and turn that into a radio that you can listen to with an earpiece. I still think it's cool, but I think students are sort of at the whatever stage of that. Kaleidoscope's pretty easy to do with a mailer tube and then some thin pieces of mirror that you can cut with a glass cutter. The DIY lasers, you can get laser gas tubes for about $5 each, and power supplies for another $15, and you've got pretty good gas lasers for about $20. You can also do it cheaper with diodes. Laser diodes are about $1 each now, and get a 3-volt power supply, and you've got a laser diode. Stirling engines are external combustion engines, and there's a really good version of this with coffee cans. I didn't get into the details here, but if you search for the Smithsonian, no, it was Scientific American. They had a column called Amateur Scientist, and there's a great article on the coffee can version of the Stirling engine. You can make versions of it with test tubes as well. I didn't get into the details on that. If you're interested, let me know and I'll track those down for you. But those are good. They just show you basically how a simple engine works. It's hard to find good stuff with thermodynamics, I find, so sometimes I do it then. Yeah. I don't even always do thermodynamics, to tell you the truth. If you ever run a physics Olympics, here's some ideas for events. Paper towers, spaghetti tower with tape, raw pasta and marshmallows. Index card tower, you give them a certain number, 5 index cards, 10 index cards, 20, whatever. Build the tallest tower. Slowest parachute if you've got a nice dropping place in your school. The longest lever you can make with craft sticks without them being attached to a desk. I didn't put a picture, but I hope you can visualize what I'm talking about. Kind of a cantilever type thing. Of course, your classic egg drop with paper. I usually just do 5 sheets of paper and a meter of masking tape, protect an egg. I haven't done these in a while. A Fermi question, list of Fermi questions to try. Strongest aluminum foil boat, hit the target sort of thing. Just some ideas for physics Olympics events. Or if you are kind of doing things at the end of the school year and you are out of time and out of student interest and you just need to have them try a few fun things. If you just got kind of a nothing day, these are all good ideas. Pinhole cameras are classic and simple if you don't mind getting your hands dirty with film chemicals. You can still get them online and trays as well. It's a pretty cheap investment for some kind of a big wow factor, I have found. So you can buy pinhole cameras that are made out of paint cans and they work pretty well, but this is cheaper. So by the way, you normally want to put a piece of black. You want to paint the inside black, flat black, and make some black vinyl on the top. Small square hole, aluminum foil on the inside, and pop a needle hole through a very clean hole. I use black and white film paper, the emulsions on the opposite side, Dektol, stop bath, fixer, and water, which sorry, you can't see it back there. You need 4 trays and a red light. I didn't get into the details here, but if you ever want, happy to walk you through it. I used to do photography stuff, and this is just sort of a holdover from that.
Like it.
This is what I would classify as really worthwhile, but not easy. And it's not expensive. In fact, it costs almost nothing. Sound triggered photography. If you have access to an old tape recorder, you can use a tape recorder as a microphone, like literally an old cassette recorder, like kind that's probably laying around in your AV room somewhere. And pick up one of these things. It'll cost you $1 or $2. It's called a silicon controlled rectifier. That's the actual official part number there. That's another number that you may find. It's the old Radio Shack number. And this has 3 leads coming out of it. And the one lead, I drew this the best I could, but one lead actually ends, and this is a PC cord which goes to a flash, a camera flash. And what this does is it creates a sound trigger flash. So literally you have the sound that comes into your tape recorder, and if something happens, like somebody claps their hand, it immediately flashes. And you can use that to take pictures of things like explosions, like
Cool.
yeah, exploding balloons. It is Harold Edgerton is kind of the pioneer. He's did all the most famous things like the milk drop and the bullets going through playing cards and stuff like that. But it's the same basic idea. And if you have a student who's really into photography and they really want to try something cool, there's a great article from 30 odd years ago in Physics Teacher. And that gets into the details, but you don't even have to look it up. It's really not that hard if you are interested. So there's the schematic for it right here. You got 3 wires coming out of this rectifier. 1 wire goes into the microphone input. Another wire goes into the microphone input. You know, you use an 1/8 inch jack or whatever. The central wire goes into the central prong of the PC cord. And then this also gets attached to the barrel of the PC cord. It sounds more complicated than it really is. If you're interested, I'll gladly get you more info. I put it in there not because I thought that most people would do it. I like it so much, and I never get around to doing it anymore, and somebody really should. If you're teaching trig and you need, this is great for just quickly going outside, determining the heights of flagpoles or trees or whatever. Just a simple altimeter with a straw and a protractor, or a simple transit. It's the same basic idea. The old classic shop vac hovercraft, you've seen those before. Nothing much to it, just as long as you can just have the patience to cut a 3-foot diameter disc out of wood. When I teach engineering, we always get into bending. We get into tensile tests, compressions tests, and I found that it was hard to find something to do good bending tests for. So this is just constructed out of some cheap wood, and that is molding that I just kind of cut with a little scroll saw there. And that way I can do different lengths of spaghetti and just hanging weights on them. We can determine when they bend, and you can find Young's modulus from that. Okay, the last few things are this kind of, this is going to be sort of under the how ambitious are you kind of umbrella. I've built telescopes before, but I find that since they don't appreciate in value, it's easy to find cheap telescopes. So the one there that's pictured, that's actually huge, and it's taller. It's about as tall as I am, I guess. But and it was like $250 or $300, and there's just a big 13-inch mirror in here, and it weighs about 100 pounds. But man, the thing is fantastic. So if you're ever looking to just have an astronomy club, you can do a pretty easy and small investment and getting a decent sized telescope. You find that people within a small drive will have them. I find them on Craigslist, AstroMart, or Cloudy Nights all the time. And if you're really feeling ambitious, build an observatory.
Wow.
Here's your simple $300 observatory, not even that much. This is not mine. I built mine years ago and I tore it down. I don't have any pictures of it, but that's PVC and it's on wheels and the whole thing just spins, and it's that simple. And then you cover it with Tyvek. There was a guy who wrote a book on this, a short book. It was available as something called Cover Your Astro. And, but that's the idea of it. I couldn't find the book anymore and I don't have my copy anymore, but that's the gist of it. It's pretty easy to see what's going on here to kind of reverse engineer that. I think that's probably just about, not like 6 foot or 8 foot in diameter. Every year we compete in something called the Kinetic Sculpture Race in Baltimore. And we basically take bikes that have been donated. We have kind of a bike graveyard. Wait, where is it? Yeah, a bike graveyard behind our school that people just bring in dozens of bikes. And we have a whole class that does this. But basically they just, the kids learn how to weld from one of our art teachers and they turn bikes into these kinds of vehicles. And they basically have to be able to pedal them and drive them into the inner harbor in Baltimore. They have to drive on sand. They have to drive in water. So we put styrofoam on them like there. And there's more styrofoam that you don't see because it's not on here at the moment. And basically they just have to pedal. It has to be all human powered. And it's a big race and it is totally fun and it's ludicrous. If you go to, I have the link in case you want to see what people are doing. But,
Does this only happen in Baltimore or do people do it otherwhere?
To my knowledge, I only know of it in Baltimore, the Kinetic Sculpture Race, but I'm sure they have it elsewhere. Baltimore is easy because we have the harbor. The inner harbor is really easy to access. In fact, there is the link for it right there.
That sounds so fun.
Pardon me?
I'm sorry, I was just saying that sounds fun.
Oh, it's fun. It's not expensive, but it definitely is labor intensive. And that's also if you want to have students weld, which, I'm not a great welder, but my art colleague is a fantastic welder and she teaches kids how to weld all the time. So, we have the setup for that. So they take most of a year and build one of these. But
yeah, we have a welding class at our school. So that just sounds amazing.
Oh, just share these ideas with them. I've had students build go-karts before because I'll teach an engineering class and we build go-karts or sometimes we'll rehab mopeds or scooters or go-peds, which are the kind you stand on. And you can have kids weld, but you can also use stuff called maker pipe. And I just found out about this a couple of years ago and it's basically just pipe that cuts easily that you don't have to weld. They just sell these joints, all these different joints, and it's great. And if you're also interested in having students build things, it's always good to subscribe to Make Magazine or just go to the Make Zine website all the time. Tons of ideas for a variety of different comfort levels. I made a list of tools I try to keep on hand for building things. This is just the general classroom tools that it's pretty good to have. A couple of lists here. Take a look and, if you feel like it. If you're, I actually have a couple of tackle boxes where I'll keep some tools around just for students to access. It's like a $10 or $15 tackle box. And soldering iron, jeweler's screwdrivers. Kids are always asking me, do you have a screwdriver for my glasses? It's nice to have tools like that, handy. If you ever decide you're going to outfit a small shop, here's this colleague of mine gave me this list, which I swore by for years. He said, you get these 10 or 12 things and you can build almost anything. So.
Yeah.
That's it.
Brilliant.
Thank you so very much. And once again, thank you. Thanks, Susan Zawacki. And if you need to contact me, that's it.
I'm taking a picture of that. I know I have it. I know I'm going to have it, but let me take a picture.
Absolutely.
Perfect. All right.
Well, Jennifer, thank you so much.
Yes, thank you for sharing all that stuff. And look at all these things.
Hey, good. Excellent. Well, now you got some fun stuff to do over the summer, so go crazy.
That's right. It's going to be great.
I check this email pretty religiously, so if you have any questions, feel free anytime to reach out. Always happy to chat with a colleague.
All right. Well, thank you so very much. You have a great rest of your day.
My pleasure. Tell Susan I said goodbye. I am going to get all of this loaded up and I'll share the whole thing with you once I do that. I'll just make YouTube clips or something out of it.
All right. Well, thank you so much.
You bet.
Bye.
See you later.